All right, so looking at 1, I saw a lot of people try to do guess and check, and I don't think that's necessary in here. And then if you did guess and check, you still have to factor a second time. What do we always want to look for first? GCF. Yep, that greatest common factor. I think we can easily pull out a 3 to make that factoring a lot nicer. Oh, not 16. How about 6? And then I'm going to factor again. I'm going to leave the 3 out, and I'm thinking 3 times 2, so I'm going n minus 3 and n plus 2. So again, I'm picturing that to be like a 1-minute question on the quiz tomorrow, or on the test tomorrow. So I have n minus 3 over 3, n minus 3, and n plus 2. And then I can say I can divide out when anybody on the top and bottom are the same, so I can divide out the n minus 3's. What's left when we do that? 1. Anybody divided by itself is a 1. So I have 1 over 3 times n plus 2. Okay, now the other thing that some people didn't say as I was walking around here, we also want to talk about what makes a fraction undefined. So there's at least 2 multiple choice questions just on that tomorrow. Undefined means you can't divide by what number? 0. So you have to look at your original equation, your original factors. How many n's are in here? 2. So there's 2 n values where this is undefined. This first one is n equals 3, and the second n equals negative 2. So I'm just going to say n cannot equal 3, n cannot equal negative 2. Again, I'm assuming you can look at that and figure that out in your head. If you can't, what are you just setting that equal to? 0, and work it out on paper if you need to. All right, number 2. What type of factoring did we have on top? GCF. So I've pulled out a 7. I've got n plus 4. On the bottom, what type of factoring? GCF again, I can pull out a n squared, and I'm left with n plus 4. So again, n plus 4 divided by n plus 4 cancels to a 1, and I'm left with 7 over 9n squared. Again, I just want to talk about what n cannot equal. So if I look, there are 2 n's in the original problem. This one, n cannot equal what number? Negative 4. This one, n cannot equal what number? Think about this. Let me just start with 9. What's 9 squared? 81. Is that going to get me 0 on the bottom? No, 1/9 would be 1 over 81 times 9. That's not going to get me 0 on the bottom. Alex, what were you thinking? Did you say something? What can this just not be? Braden? 0, right? Because I want to set n squared equal to 0, the square root of both sides. N just cannot equal 0. Okay, because that would create a 0 on the bottom. All right, take a look at the next 2. Again, talk yourself through the type of factoring. There's 2 unique factorings there. I'll give you a few minutes. All right, let's look at that third one. We'll take the easy factoring, the denominator. Hopefully we recognized as a difference of perfect. Oh, denominator, I'm going perfect squares, but then I think I heard yes. On top, you had to recognize that was perfect cubes. Okay, perfect cubes are unique. They are a formula given on the exam, so they're on the board for the tests, quizzes, etc. So you have to say to yourself, who is A and who is B? And again, that's just who am I cubing? Who am I cubing to get x cubed? X, and who am I cubing to get 27? 3. So now you just follow the formula that's given. So it's A minus B. I'm going to actually do it off to the side here. It's A minus B times A squared plus, AB plus B squared. So I'm going to have x minus 3 in parentheses x squared plus x times 3 plus 3 squared. So I'm getting x minus 3 times x squared plus 3x plus 9. Okay, so half the battle is just recognizing that you have perfect cubes. And then this, the nice part is this is always prime. This is not going to factor again in the perfect cubes. So my x minus 3's will cancel, and I have the x squared plus 3x plus 9 over the x plus 3. All right, lastly, again, I want to state what makes my fraction undefined. So I am going back to this original denominator. And here, x cannot equal negative 3, and x cannot equal positive 3. So I'm just going to call that a plus minus 3. It can't be positive or negative 3. All right, looking at 4, what type of factoring did we have to catch in the numerator? Grouping, excellent. So I've got to group off to the side. Okay, I can't just come up and put that answer. I can't factor that off the top of my head. We've got to group that off to the side. There's 3 GCFs we're pulling out. What's our first GCF? X squared, and we're left with the x minus 2. My second GCF, I have to be left with x minus 2, so what am I pulling out if I'm changing those signs? Good. And then I've got x minus 2, so that was 1 GCF, 2 GCFs. Now I pull out the binomial third GCF, which is an x minus 2, and I'm left with the x squared minus 5. Okay, so I've got to do all that scratch work off to the side before I can just stick my answer in that numerator. So I have x minus 2 over x squared minus 5. All right, so again, factor by grouping is 3 GCFs. In the denominator, who has to come first based off the way this is written? The 2. So this is going to be 2 plus x and 2 minus x. I cannot just switch those signs. Okay, keep it in that order. Who can divide out then? And the 2 minus x, what do they divide to? Negative 1. Okay, so when I write my answer, I'm either going to leave negative 1 with parentheses x squared minus 5. There was I can't remember if it was 5 or 6 of us that messed that up on that last quiz. Or you can distribute the negative to both terms, negative x squared plus 5 over 2 plus x. So either you have to have parentheses or distribute it to everybody. Okay, and then lastly, just talking about what makes this fraction undefined again, I'm going to go back to the original denominator here, and I'm going to say x cannot equal plus and minus 2. Okay, putting that undefined in is part of everything we do in a rational. All right, so the first day, that was all we did the first day. We had a ton of simplifying. The next day we hit multiplying and dividing. So just the rules for multiplying and dividing is you factor every term, factor all terms, then cancel or divide. Okay, you want to factor every term and then divide. The only thing we have to be cautious with is division itself. When we see division, what phrase are we saying to ourselves? Good. Keep, change, flip. Okay, you keep what's in front, you change division to multiplication, and then you flip what's after it. So same idea, go get 16 and 17, and then we'll regroup and compare, but you're factoring everything and dividing. So looking at 16, I don't think the first fraction can simplify at all. I just got p minus 9 over 3. There's no factoring there. Christian, how do you factor the top right?
Top right?
Yeah.
Oh, I pulled out a 3, and then I got 7p minus 6.
Perfect. And then again, I don't think there's any factoring to do on the bottom, right? So I think that looks great. Anything on the top and bottom that are the same, I can kill the 7p minus 6's. What else can I reduce? The 3's. And I think we're just left with p minus 9 for a final answer. You can put it over 1 if you want, but p minus 9 is fine. 17. Ryan, how do you factor the top left? Yep. What are you left with? K minus 1. Yep, perfect. Michelina, bottom left, what'd you factor? Perfect. Excellent. I don't think I can do anything on either of these sides. So we're just leaving that. Looking to cancel. Alex, what can divide out? 45s are gone. 45 on top, 45 on the bottom. Carson, what else can I go with? Excellent. So they are opposites. Positive to negative, negative to positive. Excellent. That cancels to a negative 1. And I think that's all I'm left with. So on top, remember, we're multiplying. Negative 1 times 1 is just negative 1. On the bottom, don't forget we have that lonely k there. and the k plus 10. I'm just writing them next to each other, or again, you can multiply if you want, or just write them next to each other. All right, bottom two here. This time we have division, and this doesn't look like a fraction, so we can easily make it a fraction by putting it over 1. And then again, it's division, so watch your keep, change, flip. Once you catch that, factor everybody. Put a few more minutes on the board here. All right, so we get our keep, change, flip. The only one that actually had to get factored was the top left, and it was a guess and check. Okay, 3 only had one option, so 3n and n. Now, 20 obviously has a couple options, but here's where you want to be smart. Remember, the whole idea is that something's supposed to cancel, right? So if I'm multiplying to 20 and my options are 2 and 10, 1 and 20, or 5 and 4, what do I see down here? 5. So I'm probably going to start with a 5 and a 4 first. I'm going to use that as a hint, and I'm going to stick it with the 3, because again, in theory, I want this to cancel. So I'm going to go 5 and 4 as my first guess. 12 and 5 can make a 7, and I want a positive 7, so I would want a positive 12 and a negative 5 to get me that positive 7. Okay. And then as far as canceling goes, the 3n minus 5 look the same, and I have nothing left in common. I have n plus 4 and 5n squared. And again, I cannot cancel these because this is not multiplication. This is the binomial x plus 4. So we're just done there. On this side, the n plus 3 doesn't factor. Bottom, I think we're pulling out a GCF. What can we pull out of there? 6m? What does that get me? M plus, does 5 sound right? Okay, so again, I've got another guess and check, 2m and m. Now again, 15, I could go 1 and 15 or 3 and 5, but if I look, I see a 5, so I'm probably going to start with a 3 and a 5. So I think I'm going to go 5 here and 3 here and check. That's a 6, that's a 10, sorry. That doesn't work, does it? Oh, yep, there we go. That's a 10 and a 3, that doesn't work. So if I go 5 and 3 here, that would be a 6 and a 5, which would get me a 1, so I need a negative 3 and a positive 5. So my 2m, thank you, Emmett there, 2m plus 5s are going to cancel, and I think that's it. So I have an m minus 3, an m plus 3, and a 6m. And again, I cannot cancel any of these m's. This is multiplication, that's addition and subtraction. So it just is what it is there. All right, so I would say those were kind of the nice easy days. Then we got into all the adding, subtracting, and equation stuff. So I'll just start with the adding and subtracting. Again, the whole idea is that you get common denominators. That is the whole point. Okay, now I think we're at the point where many of you can get the common denominator without writing common factor, uncommon factor, LCD. A lot of you could just look at it and figure it out by now. If you can, go for it. You don't have to write those out. So what do I first have to do with this left side? Perfect, I got to factor that. So what is that? X plus 4 and x minus 2. Okay, so again, if I want them to look alike, they partially look alike. They both have x plus 4, but what would this side of the fraction need so that they look alike? X minus 2. So I am just multiplying this side by x minus 2 because I want them to look alike, hence the word common denominator. The only other thing I have to catch is that what here? Negative. I got to put that bracket there so I don't screw that up. I'm going to clean up inside my bracket. That really becomes 3x minus 6. And then we're just ready to add or subtract the top here. So I've got 2x plus 1. Now I've got to take that negative and catch my bracket. So that's going to be minus 3x plus 6 all over the x plus 4 and the x minus 2. Okay, so step 1 was find the least common denominator. Step 2 is write them as common denominators. Step 3 now is to add and subtract the numerator. So if I put my like terms together, I think I get negative x plus 7 over x plus 4 and x minus 2. And there's nothing left to do there. It just is what it is, except state what x cannot equal. That is part of every rational equation. Two x's, so there's two values. X cannot equal -4, and x cannot equal +2. All right. We'll get the next one. Make them look the same, hence the word common denominator. Yeah. What did I screw up?
No,
Oh.
I have a question.
Go ahead.
Yeah.
3x squared minus 9.
Yeah,
Minus 5x minus 10.
yeah. And then how much?
Maybe it doesn't factor. It would be, but maybe it just doesn't factor, is what I'm trying to say.
Yeah.
Now, careful, you're trying to solve these, and there's no equal sign.
Oh, yeah, you're right.
You want to just
Yeah.
write it as a
Yeah.
fraction. I just don't think it does.
Yeah.
All right, Braden, to make these look alike, who do you want to multiply the first fraction by? X minus 3. And who do you want to multiply the second fraction by? X plus 2. Okay, and before you go further, just say, do they look alike? Does that look like this? If your answer is yes, you have the common denominator. And then lastly, I'm just going to be real careful with that minus. I'm going to bracket in this side so I don't mess that up and kind of clean that up. So I get a 5x plus 10. Okay, so I'm going to multiply these. So I'm going to get 3x squared minus 9x. And then I've got to distribute my negative. So I'm getting minus 5x minus 10. All over my x plus 2 and my x minus 3. Okay, and then step 3 is just to add. So I have 3x squared minus 14x minus 10 all over my x plus 2, x minus 3. And I think Tyler's been playing with this one for a while. It does not factor. Did anyone else get? I don't think it factors nicely. Okay, so again, this just is the final. If I could factor, I would. It just doesn't happen to factor. And then again, I just want to state what x cannot be. X cannot equal -2, and x cannot equal 3. And again, the reasoning is it makes that fraction undefined. Okay, so we're not getting rid of the denominators. We're not solving it. The question did not say solve. You're just writing the fractional equation or fractional expression. All right, last one in the adding section. To make your life easier, what would you want to catch here? They're opposites. So the quick way to do this is to catch their opposites, and then I just have to multiply one of them by a -1. Now you don't, obviously you don't have to do this. You can multiply this side by 4 minus x and this side by x minus 4. This is just supposed to be a lot quicker. Okay, so I'm going to get 3x over x minus 4 plus, this is a -12, and this becomes a -4 plus x, which is really x minus 4. Okay, so again, this is supposed to make your life a lot easier. Now when I add, I get 3x minus 12 over x minus 4. And now what can I do to the numerator? GCF. And this simplifies just to the number 3. Okay. So again, we're not solving for anything. It just simplifies to the number 3. Also, I'm just going to state that x cannot equal 4. Okay. All right, so that brings us to our last section that we did in this unit, was all on rational equations, meaning there is an equal sign this time, so you are solving. Okay, your goal is to solve for x. And the most important part, the thing you can't forget, is to check for those extraneous roots. Check for extraneous roots. All right, and that means you solve the problem, but it doesn't check at the end, and we call that extraneous. All right, let's work one of them out together, and then I'll give you some time to work with your partner here. So the first thing I want to do on the bottom again is factor. So I've got x minus 4 and x minus 3. Okay, and again, my goal is just to make them all look the exact same. What would I want to multiply the first fraction by? X minus 3. That's going to help us out. The second fraction by x minus 4. Does the third one need anything? No. Would you agree they look alike? X minus 4, x minus 3. X minus 4, x minus 3. X minus 4, x minus 3. You did it. That was your whole goal, is to write common denominators. Now we kill the denominators, and we just solve the numerators. So if I distribute that through, I'm going to get 3x squared minus 9x equals 2x squared minus 8x plus 6. When there's a squared, we always want to set it equal to what number? 0, good. So move everything to one side. I like to keep my x squared positive, so I'm going to move these guys this way. It doesn't matter. You can always flip all the signs. So I'm going to get an x squared minus x minus 6, I think. Again, I keep my x squared positive. I'm going to factor. Got x minus 3 and x plus 2. Tee it up and solve. I get 3 and negative 2. Now I have to remind myself that I am not done here. Don't circle that as the multiple choice answer. Again, you have to say what x cannot equal. So you just go back to each fraction and you look at the bottoms. X cannot equal what on the first one? 3 and 4. And then you look to see if you have a problem. Do we have a problem here? Yes. Which one do we have to reject? 3. So we have a problem with 3. We're going to reject 3. What's that root called again? Extraneous. I know that's in the choices tomorrow, so make sure you understand that word. 3 is extraneous. So my only solution is negative 2. Okay, only solution is negative 2. All right, let's squeeze one more in. Look at the one to the right. Factor who you can, so you can come up with your common denominator to make them all look the same. And the goal is we want them all to be the same. So I've got, does x and x minus 2 sound good there? So Tyler, what did you multiply the second fraction by? X sounds good. How about the third fraction? That sounds good. And now I think they all look alike. Everyone has an x and an x minus 2. Okay, that would do it then. Yep. And then again, notice that there's 2 minuses, so I'm going to use brackets twice. I'm going to put a bracket around this one and a bracket around this one because I have 2 negative signs. So just be careful with those negatives. That's usually where it gets us on the question. Let's see, so the first one I didn't multiply by anything, so that's 10. And I think I had minus 5x. Inside here I had 4x minus 8. So I'm getting minus 4x plus 8. I'm going to add my 5x. So that's an x, and subtract my 8. I think I get x equals 2. Okay, but I'm not done there. we got to say what x cannot equal. So if I go back, there's two x's here, right? There's x minus 2, so x cannot equal 2. And there's a plain old x, so x cannot equal 0. And then you got to ask yourself, is there a problem? And of course there is. So we're going to reject that answer. 2 is extraneous. And my answer this time would actually be no solution. Okay? Now again, don't forget, check on your calculator. Once you get an answer, try substituting it in, and that will tell you if your answer works or not. So if you need more practice with those rational equations, I threw a couple extra on there. I do have 5 questions for you to practice for homework. Just kind of again, one of each type. If I want this test to help you out this week. Like I said, if you had one rough test grade, this can be a replacement for it. I think I went 14 questions.